In the previous video, we saw a 10,000 feet view of networking in Kubernetes. In this video, we will drill down on the first important concept called services. We have already seen a service when we deployed the Spring Boot API and the static website. In both the applications, we created a service of type node port so that we could access the application from outside the cluster. For example, in the Spring RESTful API, we could access the application from outside the cluster on port 30510 and using IP of any node. We could access the same application from within the cluster using port 8080 and IP of the node. Similarly, the static website was accessible on ports 30500 and port 80. Let's rewind a bit and understand why we need to create the service in the first place. A static website was deployed as a container in a pod in the Kubernetes cluster. We deployed multiple instances of the website, and we also added and removed instances dynamically. We also saw that each time a pod comes up, it's assigned an IP from within a subnet allocated to that node. If we were to access the website without a service, we would have the following problems. First, since the IPs are internal to the cluster, we need a way to access the website from outside the cluster. Second, when a new pod comes up, we need to be aware of the new IP, and when the old one dies, we need to remove the IP from our list. Third, a service in Kubernetes should be able to look up and communicate with another service, and this communication should be seamless when pods are added, removed, or modified. All the problems above can be solved by using services. In our example, we use a service so that we have a single IP and port to access the website, even when it's hosted on multiple pods, and these pods come up or die during deployment and scaling. There are four different types of services. The first is known as cluster IP, and it makes the pod available only within the cluster. Use this when you're designing a service whose consumers are within the cluster. For example, a RESTful microservice API that is only being used by other APIs within the cluster. The second type is node port, and that's the one that we used for our static website. It makes the application available outside the cluster. It does that by opening up a specific port on all the nodes. So if you have three nodes with IP 10.1.1.1.2 and .3, and if you specify 31,000 as the port, then the application can be accessed by hitting HTTP 10.1.1.31,000 or HTTP 10.1.1.2:31,000 or 10.1.1.1.3:31,000. You don't have to worry if the particular node has a pod for your application. When you create a node port, a cluster IP is created internally. The third type is load balancer, and this is applicable mainly for cloud clusters. However, it is possible to install a load balancer such as Nginx on-premise too. When used with cloud, it will use the cloud's load balancer such as AWS ELB to route traffic to the pods. The fourth type is called external name. When we define a service, we also define the label selector that selects the pods that the service is targeting. But instead, you can specify a DNS that the service can target. This DNS is specified as spec.externalName in the YAML. This DNS can be external to the cluster too. We have already seen how to access an application from outside the cluster using node port. Let us now see a demo of how one service can discover other services within the cluster. As an example, imagine that you have a front end that needs to connect to a backend. The front end will need to know the cluster IP of the backend to connect. There are two ways for the front end to discover the backend. The first is by using environment variables, and second is by using the DNS name of the backend. Let us see that in action. Assume that a backend is the Spring RESTful API that we installed earlier, and the frontend is the static website which we want to make dynamic by accessing the Spring RESTful API. We will first deploy the Spring RESTful API and then the website. It is important to deploy the service that you want to access first so that the environment variables are available to the second service. The order is not important if you are using DNS. We will first deploy the Spring Boot API application. In the source code, go to the folder that says Kubernetes deployment and use kubectl to apply the deployment.yaml file. This creates the Spring RESTful API application and its service. Next, go to the Kubernetes static website folder and apply the static website deployment.yaml file. This will create the static website. Our aim is to see if we can access the RESTful API from the container that hosts the static website. Instead of modifying the static website, we will directly log into the static website container and curl the Spring RESTful API. To get into the container, you can either use the kubectl execute command or get an access to the Minikube Docker runtime and log into the Docker container directly. We will use the Docker container runtime. First, we get access to the Minikube Docker runtime. We have done this before in this course, so I'll directly paste the commands here. They can be obtained by running minikube docker-env. We will now look for the Docker container that hosts the Spring RESTful API. To do that, type in docker ps pipe grep static. To log into the Docker container, we use docker execute -it container name bin bash. We are now logged into the container. As mentioned earlier, there are two ways to discover another services. The first is to look for environmental variables. Let's do an env and grep for Spring. This shows the variables for the Spring RESTful API. The variables that we are interested in are service host and port. Let's see if we can use them to curl to the API. We will need to install curl to the container first. So we do an apt-get update, install curl. Once curl is installed, we can curl the API using curl http, the service host variable, :service port variable /hello name equals Mithil. We get back hello Mithil, which means the container hosting a static website can access the RESTful API service using environment variables. The second way to access is using DNS. The format of the DNS is service name.namespace. Let's try that now. It is curl http spring RESTful API service, which is the service name, dot default, which is the namespace name, the port, /hello name equals Mithil. This worked fine. Since both our containers are in the same namespace, we can ignore it. So curl http spring RESTful API :8080 /hello name equals Mithil works well too. When you write your code, you can use either the DNS or the environment variable. Note that DNS is available when a DNS server is installed in the cluster. DNS server is a cluster add-on which is installed by default in Minikube. In this video, we looked at different types of services and we also saw a demo of service discovery. In the next video, we will look at internals of how services are implemented by Kubernetes. See you in the next video.